Hello friends, welcome to yet another video from me. So last Thursday, I spoke to you about a brief introduction to data science. Okay, and I told you to become a successful data scientist, you need to have programming knowledge, domain knowledge, and statistics and maths. So maths and statistics form the foundation for any data scientist. Okay, so if the foundation is very strong, you can always build upon it. If your concepts are very clear, your conceptualization of the problem, okay, the algorithms that you build using machine learning are going to be very strong, and they are going to give good predictions and good outputs which are going to be very useful for you. Okay, so cutting down right to statistics. What is statistics? Okay, so the word statistics originates from an ancient language, Latin, statisticum collegium. So in the ancient days, the statesmen were collecting information about all the provinces and centralizing it so that the government can use it for various purposes. So you can see that even in those grand old days, people were collecting data. So statistics is the mathematical science of collecting data. And what can you do with data if you just collect it like you gather it in a basket? It has to be organized. Okay, so the science of collecting data, organizing. And why do we organize it? So that we can analyze it. Okay, collect the data, organize it, and then analyze it, look at it, study it, analyze it. And then why do we analyze it? Because we want to interpret it. We want to take some kind of interpretation out of the data. Okay, so collect the data, organize it, interpret it. And why do we interpret it? Just for us? No. We are working with other people. We need to share this information. And whatever we have interpreted has to be presented to other people, other stakeholders. And how do I present it? With a 30-minute long speech? No. I need to put it in a visual format, like a graphical representation or PowerPoint presentation. So statistics is the mathematical science of collecting data, organizing it, analyzing it, interpreting it, and presenting it. So that is statistics. Okay. Now statistics has a lot of terminologies in it. Okay, there's loads of terminologies, but as data scientists we might not need all of them, because as data scientists we need strong statistics, knowledge of strong statistics, and quite strong programming skills. But we are not complete programmers, or we are not complete statisticians. Okay, so we look at 4 important terminologies. Okay, so any science for that matter has some terminologies. So the 4 key terminologies that I'm going to talk about in this video is population, sampling, okay, population, sampling, and variance, and the 4th concept, what is it? Let me look at my notepad. A short pencil is much better than a long memory. Okay, so the 4th word is parameter. So it's not variance, it's variable. Okay, so what's a population? So let me give you an example. I'm conducting a survey on Texas. I want to find out the socio-economic situation in Texas. Okay, so I'm going to study the entire population. So what's the population of Texas? Close to 29 million. So I need information about every single person in my analysis. So that universal set, the set from which I remove tiny specks for my analysis, from which I take out data, that set of that collection of information, that is called population. Okay. Now I'm going to study the socio-economic state of people of Texas, and can I go about collecting information from all 29 million people? It's not practical. Even if I spend 1 minute interviewing a person, it would take me 29 million minutes. And 1 million minutes is close to 330 days. Let's say it's close to 1 year. So that would take 29 years for me to collect all the information about every single person. So what do? I pick out representatives from every sector, a fair enough representation from every sector. So for every million people, I pull out 100 people, representatives. Okay? Now this kind of pulling out fragments from the population here and there is called sampling. Okay? So we know what's population and we know what's sampling. What's the third one? Variable. As the name says, what's a variable? A variable is something that can vary. So what am I studying about this population? Let's say the average salary. It can vary from 0, a jobless person or a child who's not earning, to it can go up to millions of dollars based on whom we are talking about. Okay, so the variable is something that varies. It's my object of interest that I'm studying about the population. The fourth important terminology, parameter. So what is a parameter? A parameter is something that helps me define or classify a certain system. Let me give you an example. I say car A is good, it's better than car B. So the person sitting in front of me, that's you. You're asking me, based on what parameters have you come to this conclusion? So I'm saying car A has higher mileage, it has a higher capacity, and it has A, B, C, D, something like ground clearance, or maybe wheelbase, or the number of doors, or the overall engine size. So based on these parameters, I can say that car A is better than car B. So now you understood what parameters are. So some of the most important parameters that we are using in statistics are, or at least two of the most important parameters are mean and median. So most of us know what is mean. Mean is summing up all the data. Let's say I want to calculate the mean marks obtained by a student from class A, and class A has 30 people. So how do I do that? I take their scorecards, sum it all up, and divide it by 30. So that gives me the mean. So what's a median? So I arrange all the scores of all 30 students. Student A got 35, student B got 35, C got 40, D got 45, and student number 30 got 100 marks. So arrange all 30 scores in increasing or decreasing order, and then I find the middlemost score. Here we have 30 students. So to make it easy in our first go, let's say there are 31 students. Okay, the median is, I take the middlemost value, so I leave out 15 on this side, I leave out 15 on that side. So the guy in the middle, the 31st guy is in the middle, 15 this side, 15 that side, 30, and the guy in the middle is 31. So that guy, the 16th guy, whatever score he has got, that is the median. So what if there were just 30 people? How do I calculate the median? So I found out the average between the 14 and 15, or maybe 15 and 16, whichever is coming in the center. Mostly it's 14 and 15 if you calculate. Yeah, 14 and 15. So I have 14 this side, I have 14 this side, and 2 are in the middle. 14 plus 14, 28, 2 are in the middle. I take the average of these two, 14 and 15, and that average is going to give me the median. Alrighty, so we have learned some terminologies, and we saw some important, very important definitions too. So now let's find out what type of statistics do exist. Do all of them matter to us, or what type of analysis exists, and we're going to find them out. Okay, so there are many types of analysis. Okay, different ways to analyze things. Now we can do it based on quantity, like I did in the previous example, all the scores. So the average score came up to 35 per student. So I'm able to count everything, 35. So the first person got 35, second person got 45, and all the way one of those students got 100 marks. Okay, so I'm able to I'm able to measure the quantity, and I'm analyzing based on the quantity. So that is called quantitative analysis. But on the other hand, I'm making another analysis. What is that? So I'm giving an IQ test for the class. Okay, and based on the IQ test, I'm classifying the students as average, below average, above average, bright, very bright, and things like that. So I can see that in class A, the first class, the students can be. So continuing from our quantitative and qualitative analysis. So in the second case, I'm giving an IQ test to the students, and I'm finding out what their IQ scores are. And then based on that, I'm categorizing the students as below average, average, and above average. And I'm able to find out that class A has 50% of the students below average and 50% of the students above average. But class B has everybody above average, and some of them are extra bright. Okay, now if anybody asks me what's the analysis on class A and class B, so class A has students, 50% of the students below average and 50% of the students above average, but class B has 100% above average, and some of them have really high IQs. So I'm qualitatively able to analyze the population, and this is not quantified, it's just talking about the qualities. Like I walk in Starbucks and they have small, medium, and large coffees, but when I go to some other place, they have only large and extra large, something like that. Okay, so qualitative analysis is what data science mostly deal with. Okay, things that can be measured, quantitative, and qualitative analysis at times is useful. Now we are just touching briefly on all the concepts. Now coming down to statistics. So there are two major categories of statistics. One is descriptive and inferential. So as the name says, descriptive is something that's going into detail. It can describe the data. Say for example, let's take our Texas example. So my descriptive analysis is going to say there are 29 million people, 9 million people fall below the poverty line, 20 million people are above the poverty line. Out of 20 million people, 10 are working, 10 million people fall in the working category, and the remaining 10 are either retired or too young to work. So my data is getting segregated, and it's describing my data. So I can tell there are 29 million people, 10 million are unemployed, 20 million are employed. Out of 20 million, these are like this, these are like this. And even those who are employed, I can split them. 5 million are underemployed and 5 million are employed. So my analysis is very descriptive, and it can segregate people. But on the other hand, inferential. So if you remember a few minutes ago, I was talking about sampling. So instead of going to all 29 million people and interviewing them about their political inclination, so what do you think about the Republicans? What do you think about the Democrats? Something like that. I'm trying to find out the inclination. So if I interview everybody for 1 minute, it would take me 29 million minutes, and that's close to 10 years. So what do? I just randomly go to every every sector, and I interview 10 representatives from each small, tiny cluster, okay, and find out that from this sector, 3 are inclined towards Republicans and 7 are inclined towards Democrats, something like that. And all in the total, I get 2,900 representatives, and out of them, 900 are Democrats and 2,000 are Republicans. So I can say that I can infer and say that Texas has a mood and it's inclined towards Republicans in the coming elections, something like that. So inferential statistics, descriptive statistics, parameters, variable, and I introduced 2 more terminologies, and then I told you what's analysis and what is statistics. Okay, so this is your first video where I have introduced some concepts related to statistics. So coming video, we are going to go in depth. If possible, I would pull in some practical examples and further get into the details. So thank you for watching, and this is not just one random video that I'm releasing. I'm going to release a series of videos which covers the entire span of, as I know, data science. Okay, from zero, from an absolute beginner, you're getting introduced to the concept and what are all the concepts that are getting used, and all the theoretical concepts, how these are getting used in machine learning algorithms, and later on I'm going to introduce some Python programming concepts and some Python problems, and then some tiny machine learning problems. So this is a long journey, and those who are subscribed, continue to watch my videos and try to take some notes and just note down the key terminologies, and you go and do the research on them, because that is how you become a data scientist without getting any spoon feeding. You just get the dots and you just draw the lines. So that's how you become a successful, strong data scientist. And when you are very strong in tiny basic concepts, you are going to be very confident, and the algorithms that you're going to build are going to be super strong, and your interviews are going to be very smooth as well. Alrighty, so keep watching. Thanks for joining me again. If you find somebody who could be benefited from this video, be they teachers or students, share it with them. Teachers can use this to make material for teaching, and students can directly learn from here. Alrighty, so thanks once again for watching. Join me on this journey and subscribe to my channel. Give it a thumbs up if you like it, and share it with other potential people who would be benefited from it. Signing off, Jazz here. Catch you coming Thursday. Bye bye.